Okay, so looking at the first two here, in the first one I have a single compound breaking down into two elements. What kind of reaction is that? Simple decomposition, right. Okay, if I'm writing that out in words, this stuff would be trinitrogen dioxide, molecular compound. Okay, and it's breaking down into, what would this stuff be? Nitrogen. Just nitrogen, right, because it's one of the special molecular elements, as is its partner, oxygen. Okay, what should I start with for balancing? Nitrogen, biggest number, right? Biggest number is 3, right? I got 3 nitrogens on this side. I've got 2 nitrogens in the products. How am I going to make those balance? Lowest common multiple. Swapping them makes the lowest common multiple because it's 6, right? So if I multiply this one by 2, I've got 6. If I multiply this one by 3, I now have 6 nitrogens on both sides. In doing that, I give myself how many oxygens? Okay, so what needs to go here? Right. Balance now? Yeah. Okay, and that's how we do it. Start with the biggest number and you go back and forth, back and forth. Okay, second one. Okay, we've got a single element reacting with an ionic compound, producing a different element and a different ionic compound. Single replacement. All right, good job, guys. Writing this out in words, we got calcium plus iron 3 chloride. Okay, and I just quickly did this in my head, right? That there are 3 chlorines, that's -3, so, okay. Gives us iron. Do I need to put a Roman numeral beside that? No, it's an element. Elements don't have charges. I only have to put the charge, that is the Roman numeral, in the compounds that it might be in. Right now, iron is perfectly happy to have its electrons and protons be equal. Okay, so it's just iron, okay, plus calcium chloride. All right, what should I start with? Biggest number. And chlorine's the only thing that's out of balance, and it's the biggest number. Okay, so there's 3 chlorines on this side, there's 2 on this side, lowest common multiple, 6. Okay, so I'm going to put a 3 here to get 6 chlorines. Okay, when I do that, I've got to put a 2 here to get 6 chlorines. Now, when I put that 3 here, that gave me 3 calcium, so what needs to go here? 3. Okay, when I put this 2 here, it gave me 2 irons. What needs to go here? 2. Right. Okay, back and forth, okay, and you get it balanced. All right, I will give you a couple more minutes on 3 and 4, and then we'll have a look at those. All right, so for number 3, okay, we've got C6H14, so that's hexane, okay, and it's reacting with oxygen. Okay, and this stuff would be carbon dioxide. And what's that other stuff? I don't know if we've ever seen that before. Yes, right, water, guys. HOH or H2O. It's the only one you can use the common name for. Okay, just write water. All right, we have a hydrocarbon reacting with oxygen. What kind of reaction is this? Combustion. It's a combustion reaction. Okay, in a combustion reaction, I balance alphabetically and the rule of 2. Do I need both? Yes. I do. Okay, so I'm starting this with a 2. Okay, that's what the rule of 2 says to do if I have an even number of carbons, which I do. All right, 2 times 6, because now I'm going in alphabetical order. I have 12 carbons in the reactants, so I need to make sure I have 12 carbons in the products. All right, the next thing alphabetically is hydrogen. I have 28 hydrogens in the reactants, 2 times 14. Okay, luckily this always happens. Okay, and I can just put the same number over there. Okay, 14 times 2 happens to be 28 as well. Now I can count up my oxygens. Okay, I have 24 oxygens here. Okay, plus another 14 there for I believe 38. Okay, and 38 divided by 2 is 19. Okay, so we should have 2, 19, 12, 14, for our balancing numbers. Okay, questions on how that one worked? Okay. And then 4 was the last one I had up on the board, right? Okay, so for number 4, okay, I've got an element reacting with an element to form a compound. What kind of reaction is that? Okay, how did I know to put them together in that order in the products?
Because the metal always comes first.
Metal always goes first. It's making an ionic compound, metal goes first. Guys, when we get to, later this week, predicting the products of a chemical reaction, and I give you this, and there's nothing here, you'd be surprised how many times I will see CLLI in the products. Okay, I don't have a lot of tricks in the bag, okay, but that's one of the ones that I would play to check. If you remember, if an ionic compound is made, metal goes first. Okay, it's all these things that go back to those naming rules, right? Like we always have to remember those little fundamental things, okay, even when we're doing something else. All right, so this is a synthesis reaction. All right, this stuff is chlorine, one of our special molecular elements. Lithium is lithium chloride. All right, what do I need to balance? Chlorine, yeah, there's 2 in the reactants. Now there are 2 in the products. What's wrong?
Lithium is not balanced.
Is it now?
Yeah.
All right, so on Friday I said, doing it this way is a little bit easier. Going from formula to name is a little bit easier, okay? I'm going to throw a few at you now that go the other way. So let's have you guys try 5, 6, and 7. On 7, I'm giving you the formula, okay, because I don't think anyone knows that that's dodecane.
What?
Dodecane.
What are you talking about? It's so obvious.
It's so obvious, right? Yeah. 12, dodeca, right? 2 plus 10, dodeca. Something like that. Anyway, that stuff, put it in the formula there. That's how you start the reaction. Okay? All right, give those ones a try, guys. When you're doing the ones from name to formula, if there's an ionic compound, make sure you drop and swap. And here's another one to watch out for. Special elements. Okay? You got to know now which of those ones are molecular elements, because if it gives it to you in words and you forget that's supposed to be a 2, you're going to find it very hard to balance the reaction correctly. Okay? All right, so on number 5, I've got 2 ionic compounds reacting to form 2 different ionic compounds. That reaction type is?
Double replacement.
Double replacement. Okay, writing it out in words, this stuff would be magnesium fluoride, okay, plus cobalt 3 nitrate, and that'll give us magnesium nitrate, run out of space, plus cobalt 3 fluoride. Something that might be useful later. Will a reaction ever change the type of cobalt or copper or iron?
No.
No. If it's a 3+ on the reactant side, it's a 3+ in the products if it's still in a compound. Okay? That's a reaction is never going to change what kind of a multivalent metal you have. That'll be important when we do prediction. Okay? All right, number 6, copper 2 nitrate. Okay, ionic? Yeah, okay, so I'm going to go Cu, okay, NO3. Since this is a 2+ and this is a 1-, I'm going to need brackets and a 2. Okay, and it is reacting with magnesium. Okay, it says just magnesium, so an element. Okay, to form magnesium nitrate. Okay, that's a -1, that's a +2, so 2 there. Okay, and copper metal. So that would just be copper. All right, is that okay? Okay, what kind of reaction is that? Single replacement. Okay, element plus ionic compound, we're looking at single replacement. 2 ionic compounds, we're looking at double replacement. Okay, do I need to do anything balancing wise?
It is balanced.
It's already balanced, yeah. Okay, I've got 1 copper in the product. I've got 2 nitrates in the product. There are 2 nitrates in the reactants, 1 magnesium in the reactants, 1 magnesium in the products. Okay, already balanced.
Does 5 need to be balanced?
Oh, sure it does. I skipped over that. Okay. Yeah, we didn't balance. I didn't balance number 5. Not we. It's my mistake. Okay. 3 is the biggest number. I can do fluorine or nitrate. Doesn't matter which. I'll just do fluorine because it's first. 2 on this side, 3 on that side. Lowest common multiple. 6. Yeah, that one's going to happen a lot. Okay. So 2 there and a 3 there balances my fluorines. Okay. A 3 there makes 3 magnesiums. So I'm going to put a 3 there. That gives me now how many nitrates? 6. Okay, so I got to go back over here and put a 2 there to balance my nitrates. Always a good sign when that last number makes the other thing work out. Okay, now that reaction is balanced. Okay, how many people were done 7? I had 7 on the board, right? Okay, I'm going to give you just a little bit more time on 7, and then we'll go over that one. Guys, 8's on the board, so if you're done 7, okay, give 8 a try there. Okay, so we have a hydrocarbon. Whoops. We have a hydrocarbon here, so C12H26. Going to be some big numbers in this balancing. Okay, and it's reacting with oxygen gas. What does that look like?
O2.
O2, right, it's one of our special ones. Okay, all right, and it's going to produce carbon dioxide, CO2, and water, H2O. What's that? Forgot the 2? Okay, H2O. In a combustion reaction, write it as H2O. In a replacement reaction, write it as HOH. Usually easier to track where everything comes from that way. Okay, do I need the rule of 2?
Yes.
Yeah, just to make all the numbers a little more fun. Okay, we need a rule of 2 because 12 is an even number. All right, 2 times 12 is 24. So I got 24 carbons because now I'm balancing alphabetically. Okay, 2 times 26 is 52, I believe. Okay, and 26 times 2 is 52. All right, now we got to look at the oxygens. 24 times 2 is 48. Okay, plus another 26 more is 72.
74.
74. Okay, see, that's why I shouldn't add in my head. I'll just fire up the calculator for later. Okay, 48 plus 26 is 74, and 74 divided by 2 is 37, right? Okay, see, I got that one right. Okay, 37. Big numbers. Okay, on a test, I would not give you ones with giant numbers like that and make it a little easier on you. Okay, on your test, however, you could have your calculator. Okay, that would be okay. And in fact, on your unit exam, you're going to need a calculator, scientific at the very least, because when we get to mole equation calculations at the end of the unit, you need a calculator for that. Okay, if you thought those numbers were big, wait till you start talking about number of atoms and molecules. Big, huge numbers. Okay, all right, number 8. Lithium nitride breaks down into nitrogen and lithium. Did I just say nitrogen? I feel like I did. Nitrogen. Okay, Li with N. That's a +1. That's a -3. Li3N. Okay, these are the trickiest. Why? These and single replacement reactions are the ones that trick people the most. Why? What are they most likely to produce? Special elements. Okay? Decomposition reactions, synthesis reactions, single replacement reactions are likely to have special elements, and it's easy to forget. Okay? This breaks down into nitrogen. Is nitrogen a special element? Yep. Yeah. I kind of, what's the word in English? Foreshadowed that one. Okay? And then with lithium. Is lithium special? No. Okay, so now I got to balance this thing. Here's one of the rare cases where the biggest number doesn't work the first time. Okay, because if I go, oh, 3 is the biggest number, and put a 3 here, then I'm going to go, oh, wait, there's 2 nitrogens there. Oh, that's going to mess it up. Okay, that happens from time to time. Okay, we go with the biggest number because it works a lot. Okay, but occasionally this happens. Then you just erase what you had and you go, okay, I got to start with this one instead. Okay, put a 2 here. 2 times 3 is 6. 6. Now it's done. Okay, sometimes that happens.
Wouldn't it be nitrogen gas or?
We can just say nitrogen. We don't have to state that it was gas, but yes, it would be, unless this was done at an extremely low temperature where nitrogen's liquid. That would look weird though. Okay, how are we feeling about this? Okay, I mean, really, we're taking the skills we learned earlier in the unit, the naming stuff, we're applying it to something new. Okay, we have to write formulas correctly, we have to write names correctly, okay, we have to balance reactions, which once you get the hang of it and do a little practice is not terrible. Okay, and then you got to remember a few special elements along the way. Okay, I'm going to give you guys about a 5-minute break here, and then we're going to try some more. Okay, just because the only way to get good at these is repetition. You just got to do a bunch. Okay, and that's kind of what we'll be looking at here this week. I will also put up the practice quizzes. And sorry, I also want to point out that in Google Classroom, all of the worksheets that we are doing are in there, and so are the keys. Okay, so if we go in here and we go to classwork, okay, and you go to worksheet packages and other materials, okay, in there, okay, oh, nope, sorry, they were in another section. I messed up, sorry guys. They are in chemistry worksheet keys, that one right there. Okay, if you go to chemistry worksheet keys, okay, you will see all those naming keys that we did before. Okay, this file here has the keys to all the reaction worksheets. Okay, and this one for all the mole equations, but we're not there yet. Okay, so if you click on that, okay, it'll take you to this PDF where you have my ugly handwriting, but they're mostly right. So you can always check your work as you go, okay, with those. Okay, if you're doing some practice at home. Okay, so keys with the reaction stuff, okay, is really get familiar with the patterns. Okay, what does a synthesis reaction look like? What does a decomp reaction look like? Okay, make sure that you can really easily recognize those, and I'm going to add a little thing to that. Make sure you can identify them just from the reactants. Okay, because as we progress to predicting the products of a chemical reaction, all you're going to get are the reactants. And from that, you're going to have to be able to tell me that's a double replacement reaction. That's a decomposition reaction. And then use the pattern to predict what the products would be. Okay? So like I'll give you a quick example here. Right? Let's say that all I gave you was this. Okay, I have an element reacting with an ionic compound. What kind of reaction starts that way?
Single replacement.
Single replacement. Okay. In a single replacement reaction, what happens?
The metal switches out, right?
Right. In this case, the metal would switch out. Yeah. If this was a non-metal, it would switch out the non-metal. Okay. So if I know the pattern well enough to recognize it, then I can say reliably what's going to happen. So if calcium is going to swap out sodium, that means sodium is going to be alone, and calcium is going to wind up with fluorine. Okay, now did I just make an ionic compound? What do I have to do with it?
Balance it.
Yeah, like first I got to drop and swap it. Then I got to balance the whole reaction. Okay, so when you're predicting stuff, it's a little bit different because you have to do more of the heavy lifting. Okay, whereas when I give you the whole reaction, you kind of just write it down. Okay, so when you're predicting, it's not a whole lot different. Okay, that's why I'm saying while we're working on the ones where you're not predicting, really get to know the patterns of the reactions, because that's going to be what's important going forward towards predicting the products of a chemical reaction. Knowing, oh yeah, I know what happens in a double replacement reaction. I can easily say what would go together on the other side. Okay? we got 2 more there, guys. Let's try those last 2 on there and see how we do. I'll give you a couple minutes, then we'll do them together. All right, so hydrogen sulfide, ionic or molecular? Ionic, hydrogen's first, right? So H with S, this is a -2, that's a +1, H2S. Okay, and it is reacting with calcium hydroxide, Ca with OH, that's a -1, that's a +2, so like that. Okay, and that is going to form calcium sulfide, CaS, and water, HOH. Okay, everything okay with the way I wrote that? What kind of reaction is it? It's double replacement. Okay, in fact, it's an acid-base reaction, okay, like a neutralization reaction. All right, what should I balance first?
Hydrogen.
Yeah, I can balance hydrogen or hydroxide, because guess what? When I balance one, I'll balance the other, because they're together over here. Pretty sure that fixes the whole thing. Okay, everybody all right with that? Okay. Don't be afraid to ask questions as we go here, guys, okay? This is important stuff. If I was, not that you would ever do this, but if I was to only study one thing, like if I only had time to study one thing, please don't put yourself in that situation, but if I only had time to study one thing for this unit exam, it would be reactions. There are more marks on reactions than like anything else, by a significant margin. Okay, so reactions are huge, okay? Because, well, without reactions, chemistry is just boring. Or something like that, okay? All right, phosphorus. What do I need to remember about phosphorus?
It's a
Regular phosphorus.
it's a molecular.
Right, it's a molecular element. Its number is 4, right? It's P4, all right? All right, and it's reacting with oxygen. Also special, but less special. O2. Okay. What's the most special?
Sulfur.
Sulfur. Yeah. Okay. Okay, so those are going to react. What kind of reaction is that?
Synthesis.
It's a synthesis reaction. All right, now they already told us it's going to make triphosphorus, okay, dioxide. Now, I could never give you this as a prediction question. Because you could put phosphorus and oxygen together any way you wanted. Okay? They can go together a whole bunch of different ways. So there'd really be no wrong answer for your products on one like this. Okay? So you'd never get a synthesis reaction where you're making a molecular compound and having to predict it. Okay? If I give you a prediction for a synthesis, it has to be ionic because then there's a definite right answer. Okay? What should I balance first? Phosphorus. Okay, so 4 is the biggest number. 4 on one side, 3 on the other. Lowest common multiple.
12.
12. All right, so I put a 3 here to get 12. I put a 4 there to get 12. How many oxygen does that give me?
8.
Okay, so what needs to go here?
4.
All right, are we done?
Yeah.
Yeah. Okay. Not too bad, right? But are there little details? Okay, here's where people get, well, let's say, they lose a lot of marks on these for little mistakes like, if I forget this is a 4, I don't write the reaction correctly because it's not a 4. If I don't write the reaction correctly, will I get the balancing right?
No.
So if this is a 3-mark question, how many marks did you lose?
3.
Well, 2, because one of them would be, tell me what reaction it is. Okay? You'd hopefully get that mark, right? But if you don't get the swaps and drops right, or you forget a special element, you're down 2 marks out of 3 right off the bat. Okay? So it's really important to know the special elements and to do your drops and swaps, know your prefixes, all of that kind of stuff. Josh?
How do you know it's a special element?
Oh, because we talked about them last week.
Oh,
Okay, so we said that nitrogen and oxygen are special. They're 2s. Everything in group 17 that's a non-metal is a 2. Okay, phosphorus is a 4, sulfur is an 8. Hydrogen all by itself over there is a 2. Yeah. All right. Okay, so this is one of the worksheets. If you printed out the worksheet book, you have this. You can just write right in the worksheet booklet. Okay, but I would like you guys to try these ones. Okay, the first 4 here are actually, let's just do the first three, okay? Our formula, okay, you tell me the reaction type, you balance it, and you write it out in words, and then hopefully we'll have enough time to do a couple more where it's words to formula, all right? All right, so first one, we have iron, okay, and it's reacting with hydrogen chloride. Okay, and that is going to make iron, Roman numeral 2, that's supposed to be a 2. 2 chloride plus hydrogen. Okay, what kind of reaction is that? Single replacement, yep. Okay, what do I need to balance first? Chlorine or hydrogen, doesn't make any difference because once I balance one, I balance the other and the reaction as a whole. So, hey, we're all done at that point. Okay, questions on the first one? Okay. Second one, we've got sodium plus chlorine gives us sodium chloride. Okay, when we put those two together, we are looking at what kind of reaction? Synthesis. Okay, and only chlorine is out of balance right now, so if I put a 2 here, that'll balance my chlorines, then a 2 will be required there to balance the sodiums, and then everything looks good after that. Okay, and then our last one, what kind of reaction is that?
Decomposition.
Decomposition. The water is breaking down, so decomp. Okay, and we have water. The only thing you can use the common name for, okay? I have looked over a few labs where people have written salt for sodium chloride. Salt is a general term referring to any ionic compound, so please do not write salt, okay? Make sure you write like sodium chloride, okay? And same with sucrose, not sugar, okay? Sucrose. All right, hydrogen plus oxygen. Okay, biggest number is 2, agreed? But the hydrogen's already balanced, so I should probably balance oxygen. Okay, so put a 2 there to balance the oxygen and a 2 there to balance the hydrogens, and now the reaction is good. Okay, questions on that? All right, we'll work on that a bit tomorrow as well. And we'll probably start looking at predicting. And we will likely be doing our reactions lab. I'm hoping Thursday, I gotta check on lab availability and all that, but it'll be pretty quick. Okay. Remember that the lab report is due tomorrow, right? Yeah, the 17th, 8:30 a.m. on Google Classroom. Okay, submit it tonight if you haven't already. Okay, don't wait till it's like 8:28. Like, oh crap, no, I don't want that. Okay, just submit it tonight, and then you don't have to worry about it. Now, if you want it looked over, okay, today has been a pretty busy day for that, and I expect that to continue. Okay, so please come in and see me. Lunch is probably best. Okay, unless you're not taking a bus and you got a few minutes after school, but okay, scheduled help and lunch. I will be here because I have no light. Okay, and you can come and I will look over your lab. All right.